Pre-Calc BC. Today we are doing our last day of new material for Chapter 2. So we are just going to be doing a little more with 2.4, application of rates of change. So we are going to find the instantaneous rate of change for f of t equals 2t squared minus 1, and we're going to do so at t equals 2. Interpret the answer if f of t represents a position function in feet of an object at t seconds. So that just means like f of t is saying like where an object is after t seconds. So instantaneous rate of change meaning we're going to do our difference quotient. So we will have limit as h approaches 0 of f of t plus h, because we're dealing with t, minus f of t all over h, and again t is 2, so I'm going to go ahead and plug in that 2 now, but if you would like to plug it in later, that's fine. Okay, and now we'll plug this in. Watch your neatness and your notation, please. So I'm taking 2 plus h, and it's going in place of t in my equation. I'll put h plus 2. So that's f of h plus 2 minus f of 2 all over h. And I'm going to go ahead and FOIL. And 2 squared is 4, 4 times 2 is 8, minus 1 is 7. So this is going to be minus 7. Oh, I didn't plug, okay, sorry. Don't mind me spacing out. I was looking at my answer key and I realized that I didn't plug in the 2 until the end. So I was like, where's my answer? Okay, so now I'm going to distribute 2h squared plus 8h plus 8 minus 1 minus 7 all over h. And we'll see that 8 minus 1 minus 7, that cancels. So I have 2h squared plus 8h all over h, and at this point we should be in the home stretch because we are going to factor out an h. And then our h's will cancel. Plus 8. Okay, and then we're going to go ahead and we are going to plug our 0 in, and that just gives us 8. And we need a unit, and so it's going to be feet per second. Okay, and just for future notice, because you will have a video on the first day of Chapter 3 when we get there, and I recorded this video several years ago before I was A+ at my notation. So when you watch your next video and you see me go, oh, we're plugging in a 0 here, don't do that, because your calculus teachers don't like it. Just do like what we've been doing, so you don't actually show plugging the 0 in there, because that would mean you're plugging in the 0 when you still have the notation, which we don't want to do. So basically just do this like we've been doing, and then when you see me do that on the video for Chapter 3, don't do it! Because that first video that you'll watch, I recorded it a couple years ago. I just didn't want to re-record it, so I'm telling you now. Listen to me now, not the video on Friday, or whatever day it is. Okay? Alright, next. Now that I rambled. What is the rate of change of the volume of a sphere with respect to radius when r equals 2 inches? Okay, well, what we're really finding here is change in volume over change in radius. And when we get to Chapter 3, this is going to be something called dv dr. It looks like dv over dr, like it's a fraction, but it's not. This is just notation we'll use with derivatives. We'll get there in a little bit. One thing you do need to know is what the volume of a sphere is. So that's 4/3 pi r cubed. And yes, that's something you should know. Okay, so basically that's your function, and we are doing this with respect to r, and r is 2 inches. So again, we're just doing difference quotient. So limit as h approaches 0 of f of r plus h, because we're dealing with respect to radius, minus f of r all over h. And then we're doing this when the radius is 2. Okay. And now I'm ready to go ahead and plug this in. So 2 plus h and 2 are going in place of r. And I know you're like, that looks awful. Yeah, I mean, it's not ideal, that's for sure. 4/3 pi 2 cubed. Okay, so now we have to FOIL out 2 plus h cubed, or you just know the pattern. Okay, so I just paused and FOILed this out over here. It's h cubed and 2 cubed, that's h cubed and 8, and then it's the square the h times the 2, that's 2h squared, times 3 is 6h squared, and then square the 2, so that's 4, times the h, that's 4h, times 3 is 12h. Okay, so anyways, this is what it should be. You can FOIL it out if you don't believe me. Okay, so that's f of h plus 2 minus 2 cubed is 8. 8 times 4/3 is 32/3 pi all over h. Okay, and now we get to distribute a 4/3 pi to all of that. It's going to be super awesome. Here we go. 4/3 pi h cubed plus 6 times 4 is 24, divided by 3 is 8 pi h squared plus 16 pi h plus 32/3. Oops, that's supposed to be down there. And then minus 32/3 pi. Well, that's a good sign, right? All over h. Okay, 32/3 pi cancels. I'm running out of room. So now I don't really want to rewrite all of that. So I'm just going to pull out the h now. And that gives me 4/3 pi h squared plus 8 pi h plus 16 pi all over h. And my h's are going to cancel. And that gives me this. Yeah, I know these problems are all kind of the same after a while. Okay, so then we're plugging in a 0 and 0 for h, and the only thing left is 16 pi. Hooray! Now for units, be careful. We're dealing with inches, so this is change in volume over change in radius, right? So volume, your units is inches cubed, and radius, your unit is inches. But be careful, we don't want to divide these. We don't want to say inches squared, because these are inches cubed of different quantities. So this is 16 pi inches cubed of volume for every inch of radius. Okay, so for every inch of radius, the volume is changing by 16 pi inches cubed. So you would want to write it like this. You don't want to simplify that because it doesn't mean the same thing then. Inches squared would be like an area unit, and we're dealing with the change in volume over the change in radius. So this is how you would write it. All right, we have one more. Actually, I'm going to add a last one. Then you don't have to write it down if you don't want to, or you could. Actually, you know what? You're writing this on loose leaf paper, aren't you? So you totally should have room. Yeah. Okay, so we did one like this before. We're just going to do another one. Find the value of k that makes the function continuous. So reminder about continuity. Continuity means that your left-hand limit has to be equal to your right-hand limit, which has to be equal to the value of the function. In this case, it's f of 2, because that's kind of our turning point here. Okay, so when you plug in a 2, you're going to get 2k plus 24, right? And when you plug in a 2 here for x, you're going to get 2k squared. And what has to be true about those two things? In order for it to be continuous, all of them have to be equal. So those two things we're going to set equal to each other. And then, oh my gosh, guess what we get to do? If you said factor, you're right. Move everything over. Let's take out a 2. And I'm just switching colors for some reason, and then we can factor this pretty easily. So I paused this because I said we can factor it pretty easily, and then I factored it wrong. So let's try again. K minus 4, k plus 3, there we go. And so then k equals 4 or negative 3. There you go. Okay, so the last thing we're going to do is I'm going to show you how to find the limit as x approaches 0 from the left of the absolute value of 5x over x, and to find the limit as x approaches 0 from the right. Okay, so here's the thing. Obviously, we can't really give you non-calculator stuff at home because we can't police that in terms of assessments. But in the past, you've had to know how to do this non-calculator. So I'm going to show you how to do it non-calculator because that's going to be the expectation for next year. All right, so here's basically how you're going to do this. You're going to treat this as two different graphs. Think about the top and the bottom separately. You know that absolute value of 5x is going to look like this, right? If we're approaching 0 from the left, what that's dealing with is over here, right? That's dealing with this branch. So essentially, we are looking for not absolute value of 5x. We're looking for just negative 5x, right? Because absolute value of 5x, if we're approaching 0 from the left, it's really just this line. Y equals negative 5x over x. But now this is something you can do, like do with, right? Because those x's are going to cancel. And you just have the limit as x approaches 0 of negative 5, which is just negative 5. Okay, so then likewise over here, we're approaching 0 from the right of absolute value of 5x. Okay, but if you're approaching 0 from the right, that's this branch. Well, so we're just going to rewrite this. We don't really care about the absolute value of 5x going from the right because it's a piecewise. Remember, we write these as piecewise. It's just 5x over x. And again, these guys will cancel. And the limit as x approaches 0 from the right of 5 is just 5. Okay, so again, the basic idea here is that you have 5x as x is greater than 0, and you have negative 5x as x is less than 0. That's why when you're approaching 0 from the left you're dealing with this branch, and from the right you're dealing with this one. Okay, there you go. Hooray! So your homework tonight is day 9. And then tomorrow we will have a chat and we can go over any questions that you have. And then Thursday you will be taking a quiz on Delta Math. Okay, so make sure that you get logged in and do some of that practice so that you know how to use the interface on it. Okay, let me know if you have any questions. Bye.